right, so today we're going to talk about section 5.4 of absolute value functions, which is the transformation of those functions, and specifically the transformation with the variables h and k in that function. So remember that our formula for an absolute value function is f of x equals a times the absolute value of x minus h plus k. And h in that function is a horizontal shift of the parent function, and k is a vertical shift. And we'll look at an example of each so we can see that on a graph. So starting with h, I am asked to graph the absolute value function y equals the absolute value of x minus 2. So I'm going to go ahead and write the formula above this. Because that always helps me identify my a value, h value, and k value. So my a value is still 1 here. There's no number that's being multiplied by the absolute value expression. My h value is 2 because it says x minus 2. Notice that it's x minus h in the formula. So my h value is positive 2 because it matches the symbol. And then there is nothing that is added on the outside of the absolute value bars. So there is no value of k. So k is just 0. And I want to identify my vertex so I can put that in the middle of my table. So my vertex is always h comma k, and my h value is 2, and my k value is 0. So my vertex is 2 comma 0. Now I'm going to come over to my table and put that in the middle. And then I'm going to pick some points to the left and to the right of that vertex. Oop. Sorry, that's not what I want. I want positive 1 because that's lower, and then 0. I could do it like this, but then I'm skipping like 3 numbers in between, which is not what I intended to do. So I'm going to make this positive 1, and I'm going to make this 0. Sorry about that. And then I'm going to make this 3 and 4. So you're picking 2 numbers below, 2 numbers above. I could skip and go, made this like 0 and negative 2, and then made this 4 and 6, but then I would be going off my graph here for my x values. So I'm just going to count by ones. Okay, next is to figure out what my y values are for these values of x. So I'm going to do this part in my head. I know up here when we first learned about what a does to the absolute value function, I showed all of my work. But here I'm going to just go ahead and do this in my head. If it helps you to write it down, please, please do. Okay, so if I plug in 0, 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. So the value of y when x is 0 is positive 2. When I plug in 1, 1 minus 2 is negative 1. The absolute value of negative 1 is positive 1. When I plug in 3, 3 minus 2 is positive 1. The absolute value of positive 1 is positive 1. And when I plug in 4, 4 minus 2 is 2. The absolute value of 2 is 2. And remember, it should do this where it mirrors on either side of your vertex. Okay, next I'm going to plot these points. So 0, 2, 1, 1, 2, 0, 3, 1, and 4, 2. Now remember, I can lightly graph my parent function here. The parent function, the vertex is on the origin, and a value is still 1, and it looks like this. So when we're describing the transformation, we're always describing it in comparison to the parent function, which is just the absolute value of x. So compared to the absolute value of x, what does the h value, positive 2, do? Well, the graph is shifted 2 units to the right. And we have a fancy word for the word shift. We're going to say translates, or the graph is translated 2 units right. And that makes sense, right? Because we talked about how h is going to show a horizontal shift. So this moved 2 units to the right. When our value of h is positive, like it is here, it shifts right. If our value of h would have been negative, the graph would have shifted to the left compared to the parent function. And what that looks like is a plus sign after x inside the absolute value bars. We saw this when we first learned point slope form in topic 2, where because I have subtraction in the formula, if I were to subtract a negative, it would show addition here. Subtracting a negative is the same as adding. So if you ever see plus inside, that means your h value is negative. And I want to also remember that h is inside of the absolute value bars, not outside. So that's why we see it inside here. And I also want to remember that it's x minus h, not negative h, right? So we kind of just went over that. When you have let's write it as x plus h. This would mean h is negative. Okay, and just really quickly to identify the axis of symmetry, we want to identify what's the vertical line that cuts this V shape in half. So the axis of symmetry for this example would be the equation x equals 2, because that's the vertical line at 2 that cuts the shape in half. Okay, now let's look at the vertical shift. So here we're graphing the absolute value function y equals the absolute value of x minus 2 again, except the minus 2 is outside of the absolute value bars. So rather than that being an h value, it's actually the value of k. And in my formula, we add k. So because it's subtraction here, this is a negative value. My vertex is h comma k. There's nothing added or subtracted to x on the inside of the bars, meaning the h value is 0, and then my k value is -2. That point goes in the middle of my table, and I pick some values of x lower than 0 and higher than 0. And now I'm going to plug those in and see what my y values are. So if I plug -2 in to x, the absolute value of -2 is +2. And then 2 minus 2 is 0. If I plug in -1, the absolute value of -1 is +1. And 1 minus 2 is -1. When I plug in +1, the absolute value of +1 is 1, minus 2 is -1, and the absolute value of +2 is 2, and 2 minus 2 is 0. Putting this on my graph, it'll look like this: -2, comma 0, -1, -1, 0, -2, and 1, -1, and 2, comma 0. So my graph looks like this. If this is my original parent function, I can tell that it's been shifted down, right? Which is why k is a vertical shift. So the graph is translated down 2 units. What's important to remember is that a positive k value shifts the graph up, and a negative k value would shift the graph down. And we want to remember that k is outside the absolute value bars. And in this case, if we were to identify the axis of symmetry, it would once again be x equals 0 because it's on the y-axis.